Hello everybody, my name is Yashashwini. I'm studying in Sri Venkateshwara College of Engineering 3rd Sem. So today I'm back with another video. So today's subject is mathematics and the topic which we are going to discuss is basic concepts of probability theory. So let's get started. We'll see what is basic probability theory. So in the basic probability theory, the first concept which we are going to see is random experiments. So see, first before studying before reading out the definition of it, first let us know about what is random experiment. See, by listening to the word random, we'll just get to know, like, the simple words of random is nothing but choosing something randomly, like picking out something in a group. So it is an experiment performed represently which gives different results on outcomes are called as random experiment. So random experiment has, as I said, it is nothing but experiment that occurs randomly is called as random experiment. So examples in the random experiment which we can take, that is nothing but tossing a coin and throwing dice. So we'll take an example of tossing a coin. Tossing a coin, will just toss it randomly, like we'll just toss it, we'll just select head or tail randomly. And in second one, that is the rolling of dice also will just roll it randomly, and then the total outcomes in the dice are nothing but 6. So the number of outcomes is 6, and the number of outcomes will be represented randomly, that is nothing but random experiment. So now we'll see what is probability. Probability is the measure of how likely an event is to occur. So probability is nothing but how likely the event occurs. The occurring of events is called as probability. So the basic formula of probability is nothing but P of E is equals to number of possible events divided by total number of events. So this is the basic formula in the probability which we have to know, like the most important one. So next point, that is P plus Q is equals to 1, where P is equals to success of probability and Q is equals to failure of probability. The probability can almost be equal to 1 because the number of favorable cases and the number of possible cases can at most coincide with each other. So example of probability we'll see here, like the probability of giving head in tossing a coin. So this is the question, and the solution is nothing but number of possible outcomes. As I said, we'll toss a coin. So number of possible outcomes is nothing but 2, that is nothing but head and that is head or tail. In one coin, the number of possible outcomes are 2, that is nothing but head and tail. So the probability will be 1 by 2. Why 1? Because we can select either tail or either head, right? And then see, in this example only we'll take not a coin, we'll take 2 coins. Then what will be the answer? Like number of possible outcomes will be what? 4. That will be head tail, tail head and tail tail. So the probability will be nothing but 1 by 2 itself. So the next concept which we are going to see is nothing but sample space. The set of all possible outcomes in the random experiment and is denoted by S. The set of all possible outcomes in the random experiment and is denoted by S. Sample space is nothing but it is denoted by S, and the sample space is set of all possible outcomes. The possible outcomes like head tail, tail head, tail tail, all this is nothing but the sample space. Next one, what is event? It is a subset of sample space. It is denoted by E. The sample space, the event which is denoted by E. Events can be classified into single outputs or compounds, multiple outcomes. So just look into this diagram. We'll see a sample space is the set of all possible outcomes in an experiment. So as you can see here, the list HH, HT, TH and TT. This is nothing but the sample space. We can see the table. This is the table which is represent, and HT which is represented here is nothing but the events. So the next one which we are going to see is the addition rule. I guess this is the rule which everyone knows till now in the probability. So we'll see. The addition rule states that the probability of event or event A or event B occurring is equal to the sum of their individual probabilities. So it is said that the probability of A or B is nothing but probability of A plus probability of B. The probability of A or B is nothing but both both probability of A plus probability of B. So this is same like the product theorem is also same somewhat like the addition rule. That is, probability of A into probability of B will give you probability of A into probability of B. The same thing. So the next one is the random variables. So the random experiments, if real variable is associated with every outcomes and is denoted by x, y and z. So basically the random variables are denoted by x, y and z. Real variables. While tossing a coin, suppose the value 1 is associated for the outcomes head and 0 for the outcomes tail. So look at this example. While tossing a coin, suppose that the value is 1 is associated for the outcomes head and 0 for the outcomes of tail. It is said that there is a sample space of tossing a coin. So as I said you in the last slide, the sample space of a coin will be what? Head and tail. That is the two possible outcomes. So x of h is equals to 1 and x of tail is equals to 0. That is, x of h, the possible will be 1. X of tail will be 0. It is said here. Just look into the question. Outcome of head. 1 is associated for outcome of head and 0 is for associated for outcome tail. It is given in the question. So that is the simple thing which we understood. That is the only answer in this question. Okay, we'll look into the next example, that is tossing a coin twice. So I said you, tossing a coin twice, and what is the sample space? That is h tail, tail head and tt and tail tail. So this is what is the sample space. That is totally 4 possible outcomes. So xh, I will tell you what is xh. See here, that is head is represented 2 times, so it will be 2. Here head is represented only 1 time, so then that is 1. Here head is represented 1 time. Here there is no head, then that is 0. Next one, x of t, that is nothing but 0. Because hh, there is no occurrence of t, then that is 0. H tail, that is 1. Tail h, there also 1. Tail there is no occurrence of, there is 2 occurrence of t, then that is 2. Range of x, which is equals to 0, 1, 2. It will be considered as 0, 1, 2 because the 1 is represented twice. So we'll consider it only once. So it is 0, 1, 2. So range of x is 0, 1, 2 and range of y is also 0, 1, 2. So the next slide which you're going to see is the types of random variables. So first one is the discrete random variables. Second one is the continuous random variables. So first we'll see discrete random variables. If a random variable take infinite number of values. So like tossing of coins, it takes infinite, like the possible outcomes are only 6, but if we take 2 dice, 3 dice and roll it together, or if we take more than 5, 6 coins, we'll toss it once and there will be number of possible outcomes. That is nothing but discrete random variables. So if random variables take finite number of values, it means there is no end of the values which will be taken. So example of this will be tossing a coin and observe the outcomes. Next will be the continuous random variables. If a random variable takes infinite number of values, is called as a continuous random variable. It takes infinite number of values. It takes finite number of value. Finite number of value means a particular values, and infinite number of value means the countless number of values. So example will be conducting a survey on the life of electric bulbs, length of the nails produced by a machine. So I'll say you once again, discrete random variable is nothing but a particular one. Like tossing a coin, there will be only 2 outcomes, not more than that. So which will not be predictable, it is particular. Then next one, the continuous random variable means it can have infinite values. Like in a survey, we'll take, every people will be having different opinion and we never know how many people will come and how will they give us the survey. So the next topic is classical probability. So the classical probability is based on the equality likely outcomes. It appears to situations where all outcomes are equally likely to occur. The probability of an event is calculated by dividing the number of favorable outcomes by the total number of outcomes. It is as same as the probability formula. Like using the classical approach to the probability of event A denoted P of A is given by the same formula. So thank you guys. This is it for the video. I'll be back with another video. Thank you.